Good day, and welcome back to Tech Tips and Fixes. For those of you who are new to my channel, welcome. My name is Ron. I'm a retired electronics and instrument tech who, during my career, I kicked around doing all kinds of things: electronic servicing, training, tech writing, and a bunch of other techie stuff. But probably the thing I like the best to do is to fix. Whether it's an amplifier, a musical instrument, an electronic controller, or even my robot vacuum, whatever. I just like bringing stuff back to life, keeping it out of the landfill, and getting some more value out of whatever I'm getting to work on. So that's what this channel is about. If you enjoy that kind of thing, if you'd like to pick up some tips of things that I might have learned along the way or share them back with me, that would be great. Thanks for stopping in, and I hope you keep watching. Enjoy. So today's video is really a continuation of my last video. In that one, I did a simple fix on a DMX controlled light bar. That involved some basic troubleshooting to find out why a brand new light bar was completely dead. I fixed the problem, tested the basic functions, and that would mean at least the manual ones. But at that point I didn't have a working USB to DMX interface that I could use to connect my computer to the light bar. So I left the testing of the DMX functions to do on this video. The truth is USB to DMX interfaces are not all that expensive to buy, so I could have bought one, I guess, but where's the fun in that? And I knew I had some modules and components kicking around the shop that I could use to build my own interface, so I thought I could share that with you. Now here's my disclaimer. As I said before, I see myself as a fixer. I like fixing stuff, and I'll be the first to admit that I'm not as good at designing and building projects from scratch as I am at fixing. I do some of that, but the results aren't always that slick or pretty. Even so, when the need arises, I can usually put something together, a solution that works even if it might be a bit rough around the edges. That's the situation with this little DMX interface I built. It works, but it ain't pretty. So in this video I'm going to do several things. I'm going to tell you a little bit about DMX, how it works, and the software that I'm using with it. I'm going to explain what I need to build the interface. I'm going to show you how I built it, which is not that involved really. And I'm going to show the software I use to communicate with the light bar, and also with another light that I took in to repair. And then finally I'll demonstrate the lights operating under the DMX control a little bit so you can see it working. So that's what it's going to be all about. I hope you'll stick with me, and we'll get started right away. Okay, so first, a little bit about DMX. DMX 512 is actually a standard for digital communications, from lighting controllers to stage lighting and other kinds of fixtures. It supports one-way communications to multiple fixtures that can be daisy-chained together, and they use either a 5-pin or a 3-pin XLR connector to make that connection. The 3-pin is more common. DMX 512 uses unidirectional RS-485 differential signaling. That's a bit of a mouthful. And that works at about 250, I think maybe exactly 250 bits per second. The frame contains about, I shouldn't say about, it contains 512 discrete pieces of information, actually up to 512 discrete pieces of information or channels. and that information is sent repeatedly to update the fixtures with the latest control information. So with DMX, over short distances, you can get away with using standard microphone cables, but that isn't really a good idea over longer distances because of transmission line considerations. Now, microphone cables ran at about 60 ohms of their characteristic impedance, whereas DMX cables typically use 120 ohm impedance. Really, RS-45 uses 120 ohm impedance, 120 ohms impedance. And at the end of the transmission line, you should have a 120 ohm resistor across the line at the last fixture in the chain. That won't be a consideration for what we're doing here on the bench, but it is something that if you're ever installing something like this, it's very important that you use the right cable and you use the termination at the end. So the signaling of RS-45 is what I've just described, but the message structure itself is defined by the DMX 512 standard. We won't get into that detail so much. But there is a lot of good information online about DMX, and I'll put some links in the description about that. So in this video, I'm using a computer running some free software I found. It's called QLC Plus to control the lighting fixtures. But you should know that you can actually buy fairly inexpensive lighting controllers which will typically work with a minimum of setup time. Actually, one of the last times I did some DX work, I just rented a controller from our local music store, and that cost me about $15 for a couple of weeks' use. Also, I've seen a few videos online that show you how you can make a simple DMX controller using an Arduino board, and I know that you can also get DMX hats for Raspberry Pis, and that's something I'm thinking of putting together for a future video, so we'll see what happens. Okay, so a little bit about the USB to DMX interface I built. Really, it didn't involve too much building. I just took a FT1232 USB to serial interface module that I bought on Amazon for about $5 and connected it to an SP485 transceiver chip, and then I added a cable with an XLR connector on the end. So the only other component that I needed was a 33 ohm resistor that I put in between the cable shield and the ground. But a couple of other things did slow me down on this. The chip I had on hand was a surface mount package. I had a couple of these left over from a previous repair. And to connect that to the FT1232 board, I had to mount it on a surface mount to dip breakout board and then mount that on a prototyping board. So that was a bit of work, but not terribly difficult. If I did again, I'd just order up some transceivers and dip packages, and that would simplify things. So in this shot here, you just see me solder the prototyping board to the interface unit, and then I had to put some pins on that breakout board so that I could mount it on the prototyping board. So a bit of a kludgy way to do things, but it actually worked electrically and allowed me to use the chip that I had on hand. Okay, so I'm going to connect up the ground and then the VCC to the Max 485 chip. Just using this light wire up wire. I'm going to connect in the two main conductors from the XLR, pin 2 and 3, and then I'll hook on the common afterwards. One thing I haven't allowed for yet on this is a strain relief on this cable. Since this is mainly for just testing purposes, I can probably get away with a few things I wouldn't otherwise do. It doesn't have to be extremely robust for this. This is a pretty crude way of making a strain relief, but for now, maybe it'll do the job. Okay, unless I have missed something or got something wrong, I think that should work. Okay, so let's take a quick look at this QLC Plus software that I used to control these lights and test them. This software allows you to do a lot of different things, and I'm using it in a very simple way. I'm not going to show you all the functionality of it. There's lots of good stuff online about it, and I'm also not going to show you the fixture editor. Normally when you buy a fixture, the definition of that fixture is available. Sometimes you have to create one, and I had to in this case, but you may not in your situation. So I'm just going to show you how to use the basic software. So you can see on the screen the software itself, and the first step is just to start out by clicking the new workspace icon. So you hit the icon here, and then go down to the bottom where it says Inputs, Outputs, and click that. That opens up this table on the right hand side for inputs, and if you've got the USB to DMX interface connected and powered up, then you just click that and make sure that you have a check mark here. You can check down at the bottom and make sure that it actually is operating. It tells you there that it's connected to a FT232 UART, so that's correct and it is operating. And then we go across to the left hand side on the bottom and we click Fixtures, and at the top left we click the plus icon, and this is where we select our add fixture on this list of fixtures. And if the DMX fixture that you have is on the list, then you can select it. If not, that's where you have to use the additional software, the Fixture Editor, to create a fixture. And I've created a fixture here called LB252. When you select the actual fixture, it actually gives the name. It gives the mode that it's operating in. This was all set up when I created this definition file. and again the first channel address, and then the list of channels in that mode. So this particular mode has 7 channels where we've got control of the red, green, and blue lights. There's a master dimmer on channel 7. There's some additional functions, and all of that is defined in the information that comes with the fixture. We can double click that and it shows up on the left hand side, and we can select that fixture there. We can also go back to the right here and we can check to make sure that all the information is correct as has been put into the definitions. And then we go back down to the bottom left corner of the screen, we click Functions, and then we go up to the top left again to the New Scene icon. We click that and it comes up with a new scene, and we go down to the lower pane here and we click plus, and it allows us then to select a fixture we want in this scene. We select that, say OK, and then we look over here on the left, and we've got the LB252 listed in there, and we've got a tab here with the LB252 on that tab. We click that, and there we now have faders for all seven channels that we want to control. Now we have to enable these channels, so we can go up here and click this check mark right here, and when we do that, all of them get checked. You can just check individual channels and just control the ones you want if that's something you want to do. Now that we've got those all checked, we can start to control them, and my light bar is on, so I'll bring up the red fader. So I can bring up the red, but we're not getting anything until we turn up the dimmer control as well. So that's the overall dimmer on the right hand side. And then the amount of each color is on the left hand side. I'll bring the green up, and I'll bring the blue up, and we've got all of our lights. Then there's also some other functions in here that I won't go into the details, but there's ways of selecting different values between 0 and 255 which select different functions. So at that point you can just experiment with these. And that's all about all there is to it. Now one final thing that I'll just mention is that this QLC Plus software can be set up so that you can control multiple fixtures at once. So right now I've got connected up the light bar and this moving headlight that I've been working on, and you set up a new scene that has each fixture, and you can control them either in tandem or separately. I can adjust the head of the moving head light. There's its horizontal movement, there's its vertical movement. So each of those is a channel that's set up. I can also then turn on the different colors of light. I can cause it to flash at whatever speed I want. And I can actually control the focus of it, how wide a beam on that one. So it's a pretty useful piece of software. It's free, and I haven't even begun to tap all the functionality of it, but it's very useful for me to test out this equipment on the bench. So I guess that wraps up another one. We have had a chance to look at DMX, built a little interface, tried it with some software, and we can see how that software can be used in a number of different ways. There's lots of more information on that software online, and you can download it for free. So I'd encourage you to pursue that further if you're interested in DMX lighting control. And I think we'll wrap this one up there. I'd like to encourage you to like and comment and subscribe. We're going to be bringing out some other projects here pretty quick. Thanks for joining me, and we will catch you on the next one.